Welcome to the deep dive. Today, we're stepping into a world that you encounter every single day without even realizing it.
Mm,
It's the world of automation.
it really is everywhere.
It is what brings those robots on assembly lines to life,
Yeah.
what keeps factories humming, even what makes traffic lights change.
And what's fascinating is that all this complexity boils down to two key systems,
Oh,
PLCs and HMIs.
okay. Breaks down for me. What exactly are PLCs and HMIs?
Okay, so think of it this way. PLCs, or programmable logic controllers, they're the brains of the operation. They're constantly making decisions, processing information from sensors, and sending commands to machinery.
Wow.
The HMIs, or human-machine interfaces, well, they bridge the gap between us and that world.
Okay.
They're the screens and the buttons and displays that allow us to interact with and control these complex systems.
So the PLC is making the decisions,
Mm.
and the HMI is how we tell it what to do.
Exactly. And to understand how engineers build these systems, we're diving into a book called PLC and HMI Development with Siemens TIA Portal by Liam B. Okay, it's a deep dive into a powerful software that's used to create all sorts of automated systems, from small-scale applications to huge industrial processes.
So this TIA portal, it's like the control center for building these automated systems.
That's a great way to put it. It's where engineers write the instructions for the PLC, design the HMI layouts, and even simulate the entire system before it's built in the real world.
Right.
And what's really interesting is that TIA Portal takes this totally integrated automation approach, which means it brings everything together in one environment.
So instead of juggling different tools and software,
Yeah.
everything is neatly packaged in TIA portal?
Yeah,
That must streamline the process quite a bit.
absolutely. Imagine having your code, your HMI designs, your simulations, and all your data seamlessly connected.
Yeah.
That's the power of TIA Portal. It takes the headache out of managing complex automation projects.
The book specifically focuses on TIA portal V17, right?
Right.
Is that the latest and greatest version?
That's correct.
Okay.
V17 is packed with features. But what's particularly fascinating is its ability to create these virtual simulations I mentioned. Think of it as a digital twin of your automation system where you can test your logic, experiment with different scenarios, and fine-tune everything before deploying it on the actual hardware.
So it's like a virtual sandbox
Mm-hmm.
where you can play around with your automation system without the risk of breaking anything in the real world.
Right.
That's a fantastic way to learn and refine your designs.
Precisely. Now, let's say you open up TIA Portal. You're ready to start a new automation project. You're greeted with two main views, the portal view and the project view.
Two views.
Yeah.
What's the difference between them? Are they like different perspectives on the same project?
In a way, yes. Think of the portal view as your command center. It gives you a high-level overview of your project, lets you configure the hardware, and provides quick access to diagnostics. It's where you get the lay of the land before diving into the details.
And the project view, is that where the real magic happens?
Exactly. The project view is your workshop, your coding studio, your design hub. It's where you spend most of your time building the logic that drives the automation system and crafting the HMI screens that users will interact with.
So portal view is for setting the stage, and project view is for building the show.
Yeah.
I like that analogy.
Hmm.
Now, within these views, you can work in two modes, online and offline. What's the difference between those? Does it have to do with internet connectivity?
Not exactly. Online mode means you're directly connected to the physical PLC working in real time. It's like having a live feed from the factory floor, allowing you to monitor the system, tweak parameters, and troubleshoot issues as they happen.
So it's like having your finger on the pulse of the automation system.
Right.
That sounds powerful, but also a bit intimidating.
Yeah.
What about offline mode?
Offline mode gives you the freedom to work on your project independently without being connected to the actual hardware. It's like working on a draft before presenting it to the world. You can develop your code, design your HMIs, and run simulations all within the safe confines of your computer.
So you can experiment, make mistakes, and iterate without the pressure of real-time consequences.
Yeah.
That's a great way to learn and build confidence.
Now, when it comes to programming the PLC,
Okay.
TIA Portal offers a surprising amount of flexibility.
Okay.
You can actually choose from multiple programming languages to write the instructions for your automation system.
Wait, multiple languages.
Yes.
That's fascinating. I thought PLC programming was all about those ladder diagrams I've seen in textbooks.
Ladder logic, or LAD, is definitely a classic.
Yeah.
But it's not the only option in TIA Portal.
Okay.
You've also got function block diagram, FBD, structured text, SCL, graph, and even a newer language called cause and effect matrix, or CEM.
Wow, that's quite a toolbox.
Hmm.
What are the benefits of having so many languages to choose from? Doesn't it make things more complicated?
Think of it like this. Each language has its own strengths and weaknesses, and different programmers might prefer different approaches. Having this flexibility allows you to choose the best tool for the job and to cater to different programming styles.
So it's like having different types of paintbrushes to create a masterpiece. You wouldn't use a fine-tip brush for broad strokes.
Precisely. Now let's take a quick tour of these languages. Ladder logic, as you mentioned, is a visual language that uses symbols and diagrams to represent electrical circuits and relay logic. It's very intuitive, especially for those coming from an electrical background.
So if you're comfortable reading electrical schematics, ladder logic might feel like familiar territory.
Exactly. Now, function block diagram uses graphical blocks to represent functions and their connections.
Hmm.
It's a great way to visualize data flow and to break down complex processes into smaller, more manageable chunks.
So it's like piecing together a puzzle, connecting different blocks to achieve a specific outcome.
A very apt analogy. Then we have structured text, which is a textual language similar to Pascal or other high-level programming languages. It's perfect for those who prefer a more code-centric approach and for implementing complex algorithms or calculations.
So for those who think in lines of code rather than diagrams, structured text might be their go-to language.
Precisely. Now, graph is a language specifically designed for creating sequences, which are essentially sets of instructions that the PLC executes in a specific order.
Okay.
It's a visually driven language that allows you to map out the flow of your automation process, step by step.
It sounds like grph would be perfect for tasks that involve a clear sequence of events, like a production line where each step depends on the previous one.
Exactly. And finally, we have the cause and effect matrix, or CEM, which is a relatively new language that focuses on mapping out the relationships between causes and effects in your automation system.
So it's all about defining how certain events or conditions trigger specific actions. That sounds like a powerful way to create robust and responsive automation systems.
Precisely. Now, with all these different languages and the vast capabilities of TIA Portal, how do you keep your automation project organized? Wouldn't it be easy to get lost in a sea of code and diagrams?
That's what I was thinking.
Right.
Yeah.
That's where structured programming comes in.
Yep.
TIA Portal actively encourages this approach, which is all about breaking down your code into smaller, well-defined modules like chapters in a book.
So instead of having one massive tangled program, you create smaller, more manageable units that are easier to understand and maintain.
Exactly. And one of the key tools for achieving this structured approach in TIA Portal is something called user-defined types, or UDTs.
UDTs, what are those and how do they help bring order to the chaos?
Think of UDTs as custom blueprints for your data.
Okay.
They allow you to create templates for frequently used data structures, like the information associated with a motor or a sensor. Then instead of defining all those variables repeatedly throughout your program, you just use the UDT.
So it's like creating a reusable template for a document instead of typing the same information over and over again. This must save a lot of time and reduce the chances of errors.
Exactly, and it makes your code much cleaner, more readable, and easier to modify. The book actually gives a practical example using a red warning light on a windmill, the kind that warns aircraft at night.
Okay, I'm picturing a giant windmill with a flashing red light. How do UDTs come to play here?
Imagine you need to control this warning light, including its on-off state, brightness, flash rate, and any fault conditions.
Okay.
Instead of defining all those variables separately throughout your program, you could create a UDT called, say, warning light.
So the warning light UDT would act as a container for all the data related to that specific light.
Exactly. And then you can use this UDT whenever you need to access or modify the warning light's settings. It's all neatly organized and consistent.
That makes a lot of sense. It's like having a dedicated folder for all your warning light information instead of having it scattered across different files. Now, speaking of data, TIA Portal handles a lot of information flowing through an automation project. How does it keep track of it all?
That's a great question. Data management in TIA Portal is quite sophisticated, involving different levels of data, each with its own purpose and accessibility.
Okay, I'm intrigued. What are these different levels of data and how do they work together?
Let's start with global data. Think of it as information that's accessible from anywhere in your project. It's like a public library where any part of your program can borrow books.
So if a value needs to be shared across different parts of the automation system, you would store it as global data.
Exactly. Now, on the other end of the spectrum, we have instance data.
Okay.
This data is specific to a particular instance of a function block.
Instance data, function block. I'm feeling a bit lost here.
No worries, let me clarify.
Okay.
Imagine you have a function block that controls a motor. This block needs to store information about the motor's speed, current, and status.
Okay.
But what if you have multiple motors in your system?
So each motor would need its own set of data.
Precisely. That's where instance data comes in. Each instance of the motor control block would have its own set of instance data, keeping things organized and preventing conflicts.
So it's like each motor having its own personal file cabinet where its information is stored. That's a clever way to manage multiple instances of the same functionality.
Exactly. And then somewhere between global data and instance data, we have global instance data.
Okay.
It allows data to be shared across multiple instances of a function block while still maintaining some level of separation.
Okay, global instance data. That sounds a bit nuanced. Can you give me an example?
Imagine you have a conveyor belt system with multiple motors. You might want to store the overall speed of the conveyor belt as global instance data, accessible to all the motor control blocks. However, each motor would still have its own instance data for its individual speed and status.
So it's like having a team leader with access to the overall plan, but each team member also has their own individual tasks and information.
A great analogy. Now, another important concept in TIA Portal's data management is retain data.
Retain data, does that have something to do with memory?
Exactly. You can mark certain variables as retain, which means they'll hold their values even after the PLC loses power. It's crucial for variables that need to remember their state, even if the system is switched off and on again.
So it's like saving your progress in a video game. Even if you turn off the console, you can pick up where you left off later.
Precisely. Now, within these data blocks, there's another choice you get to make. Optimized or non-optimized data blocks.
Optimized versus non-optimized. It sounds like a trade-off of some sort.
You're right. Think of optimized data blocks as well-packed suitcases.
Okay.
They arrange the data in a way that uses the least amount of memory in the PLC.
So it's all about efficiency, making the most of the PLC's limited memory resources.
Exactly. The downside is that you don't have as much control over how the data is arranged. Non-optimized data blocks, on the other hand, give you full control over the data layout.
So it's a trade-off. Save memory with optimized blocks, or get more control with non-optimized blocks.
Exactly. You have the power to choose the best approach for your project. Now, let's explore how data interacts with those function blocks we mentioned earlier through something called interfaces.
Interfaces. It sounds like this is how data flows in and out of those function blocks.
Precisely. Interfaces define how a function block interacts with the outside world. They specify the inputs, outputs, and data it needs to perform its tasks. It's like the doors and windows of a house, allowing information to flow in and out.
So they're like the communication pathways for the function block.
Exactly. And within these interfaces, you have different types of variables that control how data is handled.
Okay.
You've got input variables, which are values that are fed into the function block. Then there are output variables, which are the results the function block produces after processing the inputs.
So it's like a cause and effect relationship. Inputs trigger calculations, which then produce outputs.
Precisely. Now, we also have in-out variables. These are a bit more versatile because they can act as both inputs and outputs. It's like a two-way communication channel, allowing data to flow both into and out of the function block.
So they're like multi-purpose tools that can send and receive information. That sounds efficient.
Exactly. And finally, you have static variables. These are like the function block's internal memory, storing data that's only accessible within that specific block.
So it's like a private notebook that the function block uses for its own calculations and record keeping.
A perfect analogy. What's particularly interesting about these in-out variables is that they use something called pointers to work with data.
Pointers. Now we're getting into the technical nitty-gritty. What exactly are pointers?
Pointers are a powerful tool for managing data efficiently. Instead of copying large chunks of data back and forth, pointers act like shortcuts, pointing to the location of the data in the PLC's memory.
It's like having a map that tells you where to find the treasure instead of carrying the treasure chest itself.
Exactly. This avoids unnecessary duplication and makes data handling much more efficient. Now, all this talk about function blocks, data, and programming makes me wonder about testing. How do you make sure your PLC program is working correctly before unleashing it on the real world?
Yeah, that's a good point.
Right.
Right.
That's where the magic of simulation comes in. Remember we talked about TIA Portal's ability to create a virtual twin of your automation system?
Yes. It's like a digital playground. where you can test your code without any real-world consequences.
Precisely. You can simulate both the PLC and the HMI, which means you can test your entire automation program in a safe, virtual environment.
Very cool.
But here's the question.
Okay.
How do you simulate the inputs that would normally come from real-world sensors and devices?
That's a great question. It's like creating a virtual world, but you still need to provide it with information to react to.
Exactly. TIA Portal offers two main methods for managing simulated inputs.
Okay.
The first method is using a watch table.
A watch table. Is that like a spreadsheet where you can see and modify the values of different variables?
That's a good way to visualize it. A watch table lets you monitor the values of specific tags and manually change those values to simulate different input scenarios.
So if you want to test how your program reacts to a sensor reading a certain temperature, you could manually enter that temperature into the watch table.
Exactly. Now, for larger projects with many inputs, you might want a more structured approach. That's where input mapping comes in.
Input mapping, what does that involve?
Imagine you have a system with dozens of sensors, each providing information to your PLC program. Input mapping allows you to create a virtual representation of those sensors and their inputs. You set up data structures that mirror your real-world sensors, and then you can manipulate those structures to simulate different input conditions.
So instead of manually entering individual values in a watch table, you have a more organized way to simulate a whole set of sensor readings. That sounds a lot more efficient for complex systems.
Exactly. It's all about managing complexity and making simulation more realistic. And to visualize all the simulated data, you can use an HMI.
So the HMI acts as a window into the simulation.
Yeah.
It lets you see what's happening and interact with a virtual automation system.
Precisely. You can create buttons, displays, and graphs to visualize the simulated data and even use the HMI to control the simulation itself. And for even greater efficiency, you can use pre-built HMI components called faceplates.
Faceplates. What are those and how do they save time in HMI design?
Imagine you have a motor control panel that needs to appear on multiple HMI screens. Instead of recreating that panel from scratch each time, you can design it once as a faceplate and then simply drop it onto any screen where you need it.
So it's like having a reusable template for common HMI elements. That sounds like a fantastic way to ensure consistency and save a lot of design effort.
Precisely. Faceplates are one of the many ways that TIA Portal streamlines the development of automation systems, making it easier for engineers to create sophisticated and robust solutions.
This is fascinating. But before we get too deep into the world of HMIs and faceplates, I think we need to take a break and let all this information sink in. In the next part of our deep dive, we'll explore the HMI side of TIA Portal in more detail. We've explored the power of PLCs and delved into TIA Portal's structured approach to programming. Now let's step into the world of HMI development.
Okay.
We left off talking about faceplates, those reusable building blocks for HMI design. I'm curious to learn how they actually work.
So faceplates are like creating your own custom widgets. You encapsulate a set of HMI objects, graphics, and functionality into a single reusable component. Let's say you have a motor control panel that you need to display on multiple screens.
Okay.
Instead of designing it from scratch each time, you create a motor faceplate.
So it's like having a blueprint for a motor control panel that I can easily replicate across my HMI.
Right.
That sounds incredibly efficient.
Exactly. It saves a ton of time and effort and ensures consistency in your design.
Yeah.
But what if you need to customize these faceplates for specific situations? Let's say one motor has different parameters than another. How do you tweak a faceplate without messing up the original design?
That's a great question. It's like having a cookie cutter, but
Yeah.
sometimes you need to add a sprinkle or two to make certain cookies unique. So how do you customize faceplates in TIA Portal?
That's where faceplate interfaces come in.
Okay.
Just like function blocks have interfaces to define their inputs and outputs, faceplates have interfaces to control how they interact with the rest of the HMI and the PLC data.
Okay, so these interfaces act as the communication channels for the faceplate, determining what data it can access and how it should behave.
Precisely. You can think of them as the bridge between the faceplate's inner workings and the outside world. And there are two main types of interfaces for faceplates:
Okay.
tag interfaces and property interfaces.
Two types of interfaces. What's the difference between them?
Tag interfaces allow you to connect HMI tags directly to the faceplate, giving it access to live data from the PLC. Imagine you have a faceplate for a pump. You could use a tag interface to connect it to tags that represent the pump's speed, status, or pressure.
So the faceplate becomes dynamic, reflecting the real-time status of the pump based on data from the PLC.
Exactly. That way, the faceplate isn't just a static image. It's a live window into the pump's operation. Now, property interfaces are a bit different.
Oh.
They allow you to customize the appearance of the faceplate, changing things like colors, text, or the visibility of certain elements.
So for example, I could use a property interface to change the color of a button on the faceplate to indicate whether a motor is running or stopped.
Precisely. It allows you to create visually appealing and informative HMIs that adapt to different situations. And the beauty of TIA Portal is that you can use both types of interfaces together to create truly flexible and dynamic faceplates.
It's like having both the data and the DZAB tools at your fingertips to craft the perfect HMI elements. That's really powerful. Now let's shift gears a bit and talk about navigation. If my HMI have multiple screens, how do I create a smooth and intuitive way for users to move between them?
Navigation is key to a user-friendly HMI.
Yeah.
TIA Portal offers a variety of tools for managing navigation, making it easy to create clear pathways for users to follow. One of the simplest and most common methods is using navigation buttons.
Okay, so I could have a button on each screen that links to other relevant screens in my application. It's like clicking on links to navigate a website.
Exactly. You can configure these buttons to trigger what's called a change screen event,
Right.
telling the HMI to switch to a different screen. And you can get creative with your navigation design. You can use simple buttons, menus, tab controls, or even more visually engaging elements.
The book also mentioned something called screen windows.
Mm.
What role do those play in navigation? Are they like pop-up windows that provide additional information?
Screen windows are more like embedded screens within your main HMI screens. Think of it as having a main window with a navigation menu and then using screen windows to display different content areas within that main window.
So the main window provides a consistent frame, while the content changes based on the user's selection.
Exactly. It's a great way to create a unified look and feel while providing access to a variety of functions.
Now, shifting gears again, let's talk about alarms. In any automation system, it's crucial to alert operators if something goes wrong.
Correct.
How does TIA Portal handle alarm management?
Alarms are essential for keeping operators informed and allowing them to respond quickly to critical situations. TIA Portal offers robust tools for configuring and managing alarms within your HMI.
Okay.
It all starts with defining what triggers an alarm.
So if a temperature sensor reading exceeds a certain limit, that could trigger an alarm.
Exactly. You would link the alarm to a tag in your PLC program that represents that temperature value.
Okay.
When the tag exceeds the defined threshold, the alarm is activated. But it's not just about detecting alarms.
Right.
You also need to categorize and prioritize them. That's where alarm classes come in.
Alarm classes.
Mm.
So you're grouping alarms based on their severity or type.
Precisely. You might have different alarm classes for critical errors, warnings, or simply informational messages. And for each class, you can define how the alarm is displayed and how it needs to be acknowledged.
So a critical alarm might be displayed in red with a flashing light, while a warning might be yellow with a less urgent notification.
Exactly. You can use color coding, sounds, and even text messages to create a clear hierarchy of alarms, ensuring operators focus on the most urgent issues. And TIA Portal also lets you log alarms, keeping a record of all alarm events.
So it's like having a black box for your automation system, recording all the important events for later analysis. It's incredibly valuable for troubleshooting and identifying patterns.
Precisely. Now, how do these alarms actually appear to the operator?
Right.
That's where alarm controls come in. They're HMI objects specifically designed to display and manage alarms.
So it's like a dedicated dashboard for alarms, showing a list of active alarms, their timestamps, and their status.
Exactly. And you have lots of flexibility in configuring these alarm controls. You can filter alarms, group them by class, and customize their appearance to suit your needs. You can even have different alarm controls on different HMI screens, allowing operators to monitor specific areas of the system.
It's like having a customized alarm system tailored to the specific needs of each operator and each section of the plant. That's a really powerful way to manage complex automation processes.
Absolutely. And all of this is designed to make the operator's life easier, allowing them to quickly understand what's happening, prioritize issues, and keep the automation system running smoothly.
Now, we've covered how to design and configure the PLC program and the HMI, but how do we actually get all this work onto the physical hardware? How do we breathe life into the automation system?
That's the final and crucial step, downloading your project to the PLC and HMI devices.
Okay.
And TIA Portal makes this process surprisingly straightforward.
Okay, walk me through it. What are the steps involved in getting my brilliant PLC program and my stunning HMI design onto the actual hardware?
The first step is to establish a connection between your computer running TIA Portal and the target PLC.
So it's like connecting two computers over a network or plugging in a USB drive.
Exactly. Once the connection is established, you can initiate a download from TIA Portal.
Mm.
This will transfer your entire PLC program, all the code, data blocks, and configurations to the PLC's memory.
It's like uploading a file to the cloud, but in this case, you're uploading your entire automation project to the brain of the system.
A great analogy. Now, before the download begins, TIA Portal performs some important checks. It scans your code for errors, looks for inconsistencies in your data blocks, and ensures that everything is compatible with the target PLC.
So it's like a final quality control check to make sure everything is in order before deploying the project.
Precisely. It's better to catch errors in this stage than to have them cause problems in the real world. And if any issues are found, TIA Portal will point them out and give you guidance on how to fix them.
That's a relief. I wouldn't want a tiny error in my code to bring down an entire production line.
Once the download is complete, the PLC is loaded with your program and ready to go. It's like flipping the switch and watching the automation system come to life.
Now, what about the HMI? How do we get that beautiful interface onto the physical screen?
Downloading to the HMI is similar to the PLC process, but with a few extra steps. First, you need to configure the connection settings for the HMI.
Ignition settings. What kind of information do we need to provide?
You need to tell TIA Portal how to communicate with the HMI device. This typically involves specifying the HMI's IP address, the communication protocol to use, and any security settings.
So it's like giving TIA Portal the address and the password to access the HMI.
Exactly. Once the connection settings are configured, you can initiate the download. TIA Portal will transfer your HMI project, including all the screens, graphics, and configurations, to the HMI device.
And just like with the PLC download, TIA Portal probably performs those same checks to ensure everything is compatible and error-free.
Absolutely. It's all about ensuring a smooth and successful download. Now, once the HMI download is complete, there might be a few final touches needed,
Okay.
such as setting up user accounts, configuring language settings, or calibrating the touchscreen.
So it's like setting up a new phone, making sure everything is personalized and working correctly.
Precisely. Once these final configurations are done, your HMI is fully operational and ready to communicate with the PLC. It's like watching two old friends reconnect, sharing data and working together to control the automation system.
This has been an incredible journey so far. We've gone from the basics of PLCs and HMIs to the intricate details of programming, simulation, and downloading. It's amazing to see how all these pieces fit together to create a complete automation solution.
It is indeed. But there are a few more things to consider. In our next session, we'll delve into some advanced concepts and best practices that can help you master TIA Portal and create truly sophisticated automation systems.
We've journeyed through the intricacies of PLC programming, HMI design, and even the art of bringing those creations to life on physical hardware. But I have a feeling there's still more to uncover in the world of TIA Portal.
Yeah, there's always more to learn.
What other gems await us in this final part of our deep dive?
Let's dive into some advanced concepts
Okay.
and best practices that can really elevate your TIA Portal skills. We'll explore how TIA Portal handles those moments when you're transferring changes to your PLC. And we'll uncover some expert tips to make your automation projects truly shine.
Okay, I'm ready to level up my TIA Portal game.
Great.
Let's talk about transferring changes. We touched on downloading projects to the PLC in the last part,
Right.
but are there any nuances or challenges we should be aware of?
There are indeed. One important concept to understand is what's called an inconsistent download. It sounds a bit scary, but it's simply TIA Portal's way of telling you that the changes you're making might require the PLC to reinitialize certain data blocks.
Reinitialize data blocks. Does that mean data could be lost?
Not necessarily lost,
Okay.
but it does mean the data in those blocks might revert to their default values. Think of it like resetting a calculator.
Okay.
You don't lose the calculator itself,
Like,
but any numbers you had entered are cleared.
I see. So it's a fresh start for those data blocks.
Exactly. And the good news is that TIA Portal is very transparent about this process. It will actually show you a preview of what data blocks will be affected by the download, so you're not caught off guard.
That's reassuring. So if there's any critical data in those blocks, I can back it up or take steps to preserve it before the download.
Precisely. Now, the main reason inconsistent downloads occur is when you make structural changes to a data block. This could involve adding or removing variables, renaming them, or even changing their retain settings.
So any modifications to the blueprint of the data block could trigger this reinitialization.
Exactly. It's like remodeling a house. If you change the layout of the rooms, you might need to rearrange the furniture or even get new furniture altogether.
That's a great analogy. It helps me visualize what's happening inside the PLC during an inconsistent download. Now, in some cases, you might even need to stop the PLC entirely before you can download your changes.
Right.
Stop the PLC. That sounds drastic. When would that be necessary?
This typically happens when you're making changes to the hardware configuration of your PLC system,
Okay.
like adding or removing modules. It's like trying to swap out a hard drive in a computer while it's still running.
Hmm.
You need to shut it down first to avoid any data corruption or other issues.
That makes perfect sense. And I assume TIA Portal will let me know when a PLC stop is required before I can download my changes.
Absolutely. It's all about guiding you through the process and preventing any accidental mishaps. Now, let's revisit the concept of data retention, which we explored in the previous part. Do you remember what that's all about?
Yes, it's the ability to mark certain variables as retain so they hold their values even when the PLC loses power. It's like a safety net for critical data.
Exactly. But here's the thing.
Okay.
If you download changes that affect the structure of a data block containing retained variables, those variables might lose their retained status. It's like moving a valuable item to a new container. You need to make sure it's still protected in its new location.
So I might need to double check and reapply the retain setting to those variables after the download to ensure they're still protected.
Precisely. It's an easy step to overlook, but it can save you a lot of headaches down the road. Now, another important aspect of downloading changes is something called software synchronization.
Software synchronization.
Yeah.
It sounds like it's making sure everything is in harmony.
That's a great way to put it. Software synchronization is TIA Portal's way of ensuring that the offline project on your computer is perfectly aligned with the online project running on the PLC. It's like making sure your sheet music matches the orchestra's performance.
So before TIA Portal downloads my changes, it checks to make sure that what I have on my computer is consistent with what's currently running on the PLC.
Exactly. This prevents any conflicts or unexpected behavior when the new changes are deployed. And in some cases, TIA Portal might even need to perform an upload from the PLC to get the latest version of the online project before it can proceed with the download.
So it's like making a backup copy of the PLC's current state before overwriting it with the new changes.
A perfect analogy. This ensures that any modifications made directly on the PLC while it's online are not lost during the download process.
That makes sense. It's all about preserving those valuable online changes. Now, what if I need to do the opposite? What if I've made changes directly on the PLC while online, and I want to get those changes back into my offline project on my computer?
That's where uploading comes in.
Okay.
You can use TIA Portal to upload the entire project from the PLC back to your computer. Or you can selectively upload specific parts, like a modified data block. It's like copying files from a USB drive back to your computer.
So it's a way to capture those online changes and integrate them back into my offline project.
Exactly. It ensures that both versions of your project are in sync, reflecting the latest changes made either online or offline.
But what happens if there are conflicting changes?
Right.
What if I've modified a data block both online and offline? How does TIA Portal handle those situations?
That's a great question. If TIA Portal detects conflicting changes, it won't just blindly overwrite one version with the other. It will alert you to the conflict and give you options to resolve it. You can choose to keep the online changes, overwrite them with the offline changes, or manually merge the changes.
So I'm in control. I get to decide how to resolve the conflict.
Exactly. It's all about giving you flexibility and preventing any accidental loss of data. Now, let's shift gears a bit and talk about some general programming tips and best practices for TIA Portal. We've touched on some of these already, but it's always good to reinforce good habits.
Absolutely. A little reminder never hurts,
Right.
especially when it comes to writing clean, efficient, and maintainable code. What are some of your top tips?
At the top of the list is structured programming. We've talked about this throughout our deep dive, but it's worth emphasizing again. Break down your code into smaller, well-defined modules. Think of it as writing a book with clear chapters, sections, and paragraphs.
Right. It's all about creating a logical flow and organization within the code, making it easier to understand, debug, and modify.
Precisely. And remember those UDTs we discussed earlier. They're your secret weapon for creating clean, reusable code. Think of them as building blocks for your data structures.
UDTs are definitely a game changer. What other tips do you have up your sleeve?
Naming conventions are crucial. Use meaningful names for your variables, tags, and functions. It's like labeling your spices in the kitchen. You don't want to confuse salt for sugar.
Right. Descriptive names make the code so much more readable and understandable, both for yourself and for anyone else who might work with your project in the future.
And don't forget about comments. Comments are your way of explaining what your code is doing, like leaving breadcrumbs for yourself and others to follow. Good comments can save countless hours of debugging time and make your code much easier to maintain.
It's like writing a travel journal alongside your map. The map shows you the way, but the journal provides the context and the insights.
A perfect analogy. And finally, let's not forget about the power of simulation. Use it relentlessly. Test different scenarios, push your code to its limits, and explore all the possibilities. It's much safer and more efficient to find and fix errors in simulation than in the real world.
Simulation is like having a dress rehearsal before the big show.
Right.
It allows you to iron out any wrinkles and make sure everything runs smoothly on opening night.
Now, before we wrap up our deep dive, I want to remind you that you're not alone in this journey. Siemens offers a wealth of resources for TIA portal users. We've mentioned a few already, but I want to highlight the Siemens support website.
Okay.
It's a treasure trove of information, including manuals, FAQs, application examples, and even video tutorials.
So if I ever get stuck or have a question, the Siemens support website is my go-to resource.
Absolutely. And if you need more personalized assistance, you can always reach out to Siemens directly. They have a dedicated support team that can provide expert guidance and troubleshooting.
That's reassuring. It's great to know there's a safety net in case I encounter any tricky challenges.
Absolutely. The world of automation is vast and ever-evolving, and TIA Portal is a powerful tool that can help you navigate that world. Don't be afraid to experiment, explore, and push the boundaries of what's possible.
This deep dive into TIA Portal has been an incredible journey. I feel like I've gained a whole new understanding of automation and the tools that bring it to life. Thank you so much for sharing your expertise and for guiding us through this intricate world.
It's been a pleasure. Remember, learning is a continuous process, especially in a field as dynamic as automation. Embrace the challenge, never stop exploring, and enjoy the journey of creating amazing automation solutions with TIA Portal.